today discuss voltages and currents for dissipation less line, right? The line is dissipation less line. The attenuation constant alpha becomes 0. The attenuation constant alpha becomes the 0, right? So the transmission line for voltage and current equation, at the receiving end the L is equal to X. L is equal to the length, the L is equal to X. At receiving end voltage and current equation V is equal to VR ZR plus Z0 divided by 2 ZR into e power gamma X plus ZR minus Z0 divided by ZR plus Z0 e power minus gamma X. So this is a voltage expression of the transmission line at receiving end. The current equation I is equal to IR into ZR plus Z0 divided by 2 Z0 into e power gamma X minus ZR minus Z0 divided by ZR plus Z0 into e power minus gamma X, right? We know the e power gamma X, it is a incident wave. E power minus gamma X is the reflected. E power minus gamma X is the reflected wave. So rearranging the above voltage and current equation, right? Rearranging of V and I, the voltage and current equation V is equal to VR by 2 ZR into ZR plus Z0 e power gamma X plus ZR minus Z0 e power minus gamma X. The current equation I is equal to IR by 2 Z0 into ZR plus Z0 e power gamma X minus ZR minus Z0 e power minus gamma X. For zero dissipation line, we know the zero dissipation line Z0 is equal to R0. Alpha is equal to 0. The dissipation line alpha is equal to 0. So the gamma is equal to only J beta. Right? So the gamma L, the length L is equal to X, we are substituting X, right? So the equation V is equal to VR by 2 ZR ZR plus Z0 is equal to R0. r naught into e power gamma x plus zr minus z naught, sorry, z naught we write to r naught e power minus gamma x, e power minus gamma x. So we substituting gamma x only, then I is equal to IR to z naught, z naught is equal to r naught, zr plus r naught e power gamma x minus zr minus r naught e power minus gamma x. So we substituting the gamma value j beta x, substituting the value of j beta. Another, the voltage and current equation, simply gamma is equal to j beta, gamma is equal to j beta, we substitute. So V is equal to PR by 2ZR, ZR plus R naught e power j beta x plus ZR minus R naught e power minus j beta x, j beta x. Alpha is equal to 0 because the 0 dissipation line. I is equal to IR by 2 R naught ZR plus R naught e power j beta x minus ZR minus R naught, ZR minus R naught e power minus j beta x, right? Only we take the ZR term, so V is equal to VR by 2 ZR, take the common e power j beta x plus e power minus j beta x, right? So this two inside the multiply this two, so VR by ZR, just we simply write this two is just to take this, right, plus R naught e power j beta x, this is a minus R naught, so minus e power minus j beta x divided by 2. The formula of sin beta x, just we multiplying denominator numerator by j, right, j, right? So that is equal to VR by ZR, right? So the VR by ZR, we know the VR by ZR into ZR into this is a cos beta x plus j R naught sin beta x, so VR by ZR, so VR we simply write IR into ZR, here we simply write to the IR into ZR, right? So VR is substitute IR into ZR divided by ZR cos beta x plus j R naught sin beta x, right? ZR cancel, so IR into ZR cos beta x plus J IR R naught sin beta x. So IR into ZR we can simply write to the IR into ZR we can simply write to VR. V is equal to I into R. So that is equal to the voltage expression of the dissipation less line. V is equal to VR cos beta x plus J IR R naught sin beta x. Sin beta x. This is the voltage expression of the dissipation less line. Similarly, the current equation I is equal to IR by 2 R naught. Take the ZR as common. ZR into e power j beta x. ZR into e power j beta x. This ZR is a minus. So minus e power minus j beta x. This 2, take the formula. This 2 is this side divided by 2 plus R naught. Take the R naught e power j beta x. This R naught is a plus, minus 2 is minus the plus e power minus j beta x by 2. So this is a current. So again we see, after rearranging the current equation, IR by R naught into R naught. Take the R naught this side. R naught into e power j beta x plus e power minus j beta x divided by 2. This term is plus ZR, the formula of sin beta x. So j ZR e power j beta x minus e power minus j beta x divided by 2j. J is multiplying both numerator and denominator, right? So the R naught IR by R naught into cos beta x plus j ZR sin beta x. So IR we can R naught, this R naught and this R naught is a cancel. So IR cos beta x. So IR multiplying this side, IR into R naught multiplying this side, IR into ZR is equal to VR. So J VR, this R naught is divided by R naught sin beta x. Finally, the current equation of the dissipation less line is I is equal to IR cos beta x plus J VR by R naught sin beta x. The voltage equation of the dissipation less line, V is equal to VR cos beta x plus J IR R naught sin beta x. Right? The transmission line and the open circuited transmission line at open circuited condition, there is no any current flow. There is no any current flow in the open circuited condition. Open circuited condition, IR is equal to 0. IR is equal to 0. There is no any current flow. The voltage expression of the open circuited condition, V is equal to this term, IR is equal to 0. Only the voltage expression is VR cos beta x only. I is equal to what is the expression of I? I is equal to VR by R naught sin beta x. R naught sin beta x. Right? Under the short circuit condition, in the short circuited condition, VR is equal to 0 because shorting voltage, the circuit is short circuited, the voltage is 0, current is maximum, right? So VR is equal to 0. The expression of voltage V is equal to J IR R naught sin beta x. The current expression I is equal to IR cos beta x. This is a dissipation line. In the open circuit condition, the expression of the voltage and current, and short circuited condition of the dissipation line, it is a voltage equation, this is a current equation. Right? Thank you.